Hey everyone, welcome to, sorry that was weird, welcome to homework 4.1. If you did not finish your classwork informative, I strongly recommend you finish that at home tonight. If you need to, I will take a look at it if you let me know that you need me to look at it again. All right, so here are a few pairs of positive numbers whose sum is 50. Find the product of each pair of numbers. So this, when we add these up, it will equal 50, right? And so then we want to think about what would the product be. So 1 times 49 is 49. The product, remember, means multiplication. 2 times 48 is 96. 10 times 40 gives us 400. All right. Find a pair of numbers that have a sum of 50 and will produce the largest possible product. So remember, when we were thinking about our shapes today and trying to find the largest possible area, the place where it was the largest area, when we multiplied something times something, the length times the width, to get the greatest number, the greatest area, we wanted to look at where one of them was not smaller than the other. Right? In other words, when are they equal to each other? And so in that case, a pair of numbers that have a sum of 50 and produce the largest possible product would be 25 and 25, which will be, I believe, 625. If you were to multiply anything that is less than or greater than that, so for example, 24 times 26, those add up to equal 50 as well, we get 624, so slightly less than that, right? Or 23 times 27, we get 621, which is less than that. Okay, and so this, when we multiply a number times itself, is going to give us the largest possible product. And then again, you can notice that if we, so when one number increases, the other decreases. These two numbers are the same and make the greatest product. All right. Here are some lengths and widths of a rectangle whose perimeter is 20 meters. So when we add it up, it is 20 meters. Notice that also means when we add up just a length and a width, it should equal 10, right? So length plus width equals 10. The area then would be 9. Here is 21. 5, then we need it equal 10, so this would be 5. This would be 25. 7 would be 3, is 21. And then 9 and 1 would be 9 again. So notice what we have happening here is we're going up until we get to 25, and then we're going back down. Notice here that these numbers, 3 and 7, are the same here. They've just flipped. And so we'll still have the same square area when we change the length and the width. Without calculating, predict whether the area of the rectangle will be greater or less than 25 square meters if the length is 5.25 meters. So 5 times 5 is where it is a square, and therefore maximizing our area. So this would be less because 5 times 5 is going to give us the largest area. All right. On the coordinate plane on the next page, plot the points for the length and area from your table. How did the values change? All right, so 5, this is 1, 2, 3, 4, 5, 6, 7, 8. I'm just going to create little hash marks here to help me keep track of where those all are. So we looked at when it's 1 meter in length, it's 9 meters wide, and our area is 9. So 1 meter length, we have 9 square meters. When it's 3, it's 21. So 3, we would be here. 5 was 25. The next one we have was 7 is 21. And then lastly, we looked at 9 is about there. So here again, we can see that the shape is forming a parabola. And so again, it goes up until it reaches the maximum possible area and then comes back down. All right, the table shows the relationship between x and y, the side lengths of a rectangle, and the area of a rectangle. So we have, again here, x and y, these are side lengths, and then the area. Explain why the relationship between the side lengths is linear. So it is linear because the y value increases by the same amount each time, right? So here we're adding +4, +4, +4. Now here we're going up by 2, so notice we're not going up by 1s incrementally, but still we're adding 4 each time. And so when that pattern is there that we're adding each time, we know it's going to be linear. And then explain why the relationship between x and the area is neither linear nor exponential. So the area and this relationship is neither linear nor exponential because it increases and then decreases. We also notice here are not multiplying by the same number each time, nor adding by the same number each time. So when we go from 8 to 32, we are multiplying by 4. But when we go from 4 to 72, we're not multiplying by the same number, right? So you can also say something about that. 72 divided by 32 gives us 2.25. So here we're multiplying by 2.25. So we can also say no constant slope for linear and no common factor, right? We're not multiplying by the same time each time, and that would designate an exponential relationship. Number 3, which statement best describes the relationship between a rectangle side length and area as represented by the graph? All right. So as the side length increases by 1, the area increases and then decreases by an equal amount. As the side length increases by 1, the area increases and then decreases by an equal factor. As the side length increases by 1, the area does not increase or decrease by an equal amount, or as the side length increases by 1, the area does not change. Okay, so we can obviously eliminate this. We also know that each time we are not increasing by the same amount, right? It's changing over time here. So we know it's not by an equal amount. It's also not by an equal factor, not multiplying by the same amount every time. So as the side length increases by 1, the area increases and decreases, but not by an equal amount, okay? So it does not increase or decrease by the same amount each time. It's changing. The amount is increased here, it's greater here, and then less here. But we're also not multiplying by the same thing either, because you'll notice then it's decreasing afterwards. Number 4, copies of a book are arranged in a stack. Each copy of a book is 2.1 centimeters thick. Complete the table. What do you notice about the differences in height of the stack of books when a new copy of the book is added? So when we have 0 copies of the book, then we have 0 height. 1 copy is 2.1. 2 copies, so we add another book on top of that would be 4.2. Then we add another one, would be 6.3. Add another one, 8.4. So here the difference in the height is plus 2.1 each time. And then the factor here, though, is not constant, right? So 4.2 divided by 2.1 gives me 2, right? So here it's times 2, but then 6.3 divided by 4.2 is a factor of 1.5. So there are different factors. Now in this case, this is a linear relationship because we are adding 2.1 each time. That's a decimal. How high is a stack of B books? So a stack of B books is 2.1 times B. Oops, 2. Let me rewrite that. It's a little bit better. Equals the height. All right, the value of a phone when it was purchased was $500. This is review. It loses a quarter of its value each year, which means that 4/5 remain, or 0.8%, or 80%, 0.8 remains. What is the value of the phone after 1 year? So that would be 500 times 0.8, or 4/5 of that. You can go ahead and calculate that on your own.
Good afternoon, Jefferson Middle School Academy, please.
And so remember that this is an exponential relationship. So for 2 years, we would do 500 times 0.8 to the second power. And in 3 years, 500 times 0.8 to the third power. So again, you can calculate these. I should see your answers there. That will tell me that you listened because you filled that out. All right, Tyler says that the value of the phone decreases by $100 each year since 1/5 of 500 is 100. Do you agree with Tyler? Explain your reasoning. So here we should say no, because this is an exponential relationship, and 100 is what it loses the first year, but then we take 1/5 from the new amount, which will be 400. But we'll take 1/5 from the new amount, which is going to be less than 100. Remember, with those depreciating values, it starts off by losing a lot more because we have a lot more to lose. And then over time, that amount that we're losing decreases. All right, that is it for your homework today. Nice, short, and sweet. Please go ahead and fill in your code word for today. Your code word for today is ink. Ink is your code word. If you have any questions, reach out. Happy homeworking, and see you tomorrow.